Hi everybody, I'm back. So let's try a more complex example when determining cis-trans isomerism. So again, following our algorithm, let's identify the carbons making the double bond. Right here and right here. And now, on each carbon, we're going to examine the groups bound to determine a priority using the Kahn-Ingold-Prelog system, which essentially asks us which one has the higher atomic number. Okay, so let's start on the right this time. So we can see, like we dealt with last time, both of our groups directly bound to our carbon making the alkene are carbon atoms. So what we need to do is we need to work our way outwards to find a difference to determine priority. So this carbon, in addition to being bound to this central alkene carbon, is bound to two hydrogens, right here. They're not shown because we're in line bond structure mode, and one other carbon. Okay. This carbon, on the other hand, is bound to two hydrogens and a chlorine. Okay, so now we compare what this carbon is bound to what this carbon is bound to, and we can say with certainty that chlorine has a higher atomic number than carbon. And because of this, the substituent down here will have the higher priority. Okay, and keep in mind, even though we have this iodine sort of tantalizingly placed all the way out here, we're not actually ever going to get to that. It's sort of there to trick you. And remember, because we're looking for the first difference that we can find, not necessarily a difference way out on the end. Oftentimes you'll see differences with double bonds that are things that are bound directly to what we're trying to establish priority. The way in which we treat them is we treat them as two bonds to that element. So let me give you an example. Right here, both our groups are carbon atoms directly bound to our alkene. So we're going to have to determine which one of these has a higher priority by looking at what's bound to it. This carbon up here is bound to two hydrogens and an oxygen. Whereas this carbon down here is bound once to an oxygen, bound twice to that oxygen, and then bound once to the hydrogen. Both of them have an oxygen, which sort of cancels each other out. And then of the remaining two things, we can see that oxygen has a higher priority than hydrogen up here. So in terms of priority, we're going to give it to this what we call an aldehyde group here, which is this bottom. So now that we've determined priority on both of our two carbons, we draw in our rigid plane, and we can make the assessment that our two groups of priority are on the same side of our rigid plane here. And in doing so, we can say that this is a cis alkene. Okay? So we're going to continue to talk about this for a little bit on Friday, just to practice a little bit. But for now, what we'd like you to do is, using what you've learned here, try and practice a little bit on some of the Blackboard problems that we've given. And I think that you'll notice that it's really not that bad once you give it a couple of tries. Okay? Hopefully you stay warm on Wednesday, even though it's super cold. And if you have any questions, be sure to send Dr. Peterson or myself an email. Have a nice one.